So we're going to introduce a new term today called the slope of a line. The slope of a straight line. So last time we learned what a linear equation in two variables is, and we saw how to graph it. So today we're going to see how to introduce a new term and see what that is. Also going to learn how to calculate this, the use of this slope. So let's first define the slope. So to understand the slope better, let's use a couple of graphs. So last time we learned what a linear equation in two variables is. So we learned something like this. So we have ax plus by equals some c. So this is the standard form of linear equations with two variables, x and y. And this usually is a graph. When you graph this on a line as a straight line, we saw last time how to graph this type of equation and also how to check whether a pair x and y is a solution. So I'll talk about this in detail in the previous lecture. So we're going to continue on still with the lines today, but we're going to introduce a new term, like I said, the slope. So to understand the slope better, we're gonna need a couple of graphs or a couple of lines. So let's draw the first one, maybe like this. The second one, a little like that. It doesn't have to go through the center, but something like this. So if you look at these two lines, well, one of them is more slant than the other. So this one goes up or slants a little slower or easier, but this one is much diagonal, is closer to the y-axis. Okay, so if you think of this as a flight of stairs, for example, this one is you could say this one is a little less to climb as opposed to this one. Okay, so in mathematics we have a term for this, and we have a quantity that measures actually the steepness. This is what we call the steepness of a line. So that quantity is called the slope. So these two lines have different slopes. That's why one of them looks more slanted than the other, or steeper than the other. Okay, so you can say that this one is steeper, as you can see, because it's more, again, it's closer to the y-axis. It tends to be more closer to the vertical axis here. So we say this line here and this line, they have two different slopes. We can say that this one is steeper than the other. For example, this one here is steeper than this one. And we use the slope to measure that. So slope measures the steepness of a line. So the slope, which we call m. Okay, that's the symbol for slope. The slope m is, or measures, actually, I'll just say it's slope m is the steepness of a line. Okay, so it's again, it's a quantity, it's a number that we can measure, and based on that number, even if we don't see the graphs, we can tell which one is more, which one is steeper than the other. All right, so if this was, for example, let's call this slope 1 or m1, okay, for this line. Let's call this slope 2. So from here, we can actually say the line 1, so this is line 1 or line 2, and this is line 1. Just from the graph, you can tell that this one is steeper, therefore it has a higher slope than this one. So we can say line 1 is steeper line 1 is steeper than line 2. In other words, actually it's the other way around. Line 2 is steeper than this, so this one is steeper. So line 2 is steeper than line 1. Therefore, the slope of this line is higher than the slope of the other. Okay, so that's the whole idea of slope. Again, it's a number, it's a quantity that we can measure. It measures how steep or how slanted a line is. In this case, you can see these two lines. Think of them as two flights of stairs or a couple of hills. Okay, so the harder the hill, or the steeper the hill is, the harder it is to climb. So we say it has a higher slope. Okay. Now we're going to see how to actually find or measure that slope. Okay, finding or measuring the slope, calculating the slope. So in order to do so, we need 2 points, 2 coordinates of a line. Let's say, for instance, this one here. Use maybe this point and maybe some other point. So to find the slope of a line, we need 2 points that belong to that line. And for example, so this probably here is about 3. This is 1, and this is maybe, let's consider this to be a 1. So we have point A and point B. So let's get the coordinates of both these points and then see how to use those coordinates to find the slope. So this would be line 1. So the slope for that line, let's call it M1. Well, before that, let's get the coordinates. What are the coordinates of this point, by the way? Point A here. This point here. What are the coordinates? Let's call this point A and point B. What's the X and Y on this point? Everyone, what is the X coordinate? Again, this is the X axis. This is the Y axis. At this point A, what's the X and what's the Y?
X is 1. X is 1 and Y is 1.
Y is not 1, Y is here.
0, 0.
Okay,
Yes.
well, X and Y are 0 here. So at this point, X is on the X axis. For the Y, you dropped it on the Y. This is the Y axis. We have 0, so that's 1, 0. And then what are the coordinates of the point B? So the X is?
X is 3.
That's right, 3.
And Y is 1.
That's right, Y. We just dropped that point on the Y axis, and it's 1. Good, so we need 2 points to find the slope. Once you have those 2 points, we have a formula called the slope intercept form. The slope, not the slope intercept form, actually the slope formula. So the slope formula is this. So M is what we call rise over 1. So Y2 minus Y1 over X2 minus X1. So remember this formula. We're going to be using it often with these lines. So to measure the slope of any line, you need these values, and these values basically come from here. So we need 2 points, and this is where you get these 4 values from. So A1 is x1, y1. Okay, that's the first point. Then you label the other point, call it x2, y2. Okay, so this is point, first point. This is the second point. So x1, y1, x2, y2. All you have to do now is take these and plug them into the formula. So we're going to take this and this one as well. We're going to plug them into this formula and simplify it, and we'll get our slope. Could be a whole number, could be an integer, could be a fraction. So it's plug. So m is, what is y2 from these values? Y2 is here, that's 1.
1.
Minus y1. What's y1? Is
0.
right? And then you have x2, which is given here 3, minus x1, minus x1,
1.
1 is 1. So you take 2 points, you label them. This first point x1, y1, x2, y2, and then you simplify, so you get 1 over 2. Simplify the fraction if possible, if not, so that's the slope. So for this line, the slope is this, okay? M1 is 1/2. Okay, so we're gonna do the same thing. We're gonna try to find the slope of this second line here. Okay, we called it M2, same way. So we're gonna try to make a couple of points in this graph. And so this was line 1, let's do line 2. All right, so as always, let's make a couple of points here. So if you have, for example, 1, maybe 2 here, 3. You can take any 2 points from the graph, it doesn't matter. So let's say maybe take this point here and this one here. This is about 1. This is -1. You can take any points, either this or this or that, or any point from here. Let's take maybe another one here. So if this is 3, so 1 is probably about 2 here. Okay, so this is about 2. Okay, usually we would have a graph in paper. It will have all the numbers on it for more accurate results. But here I'm just estimating. But this is approximately what it would look like on graph in paper. Okay, so same thing here. Let's take 2 points. Any 2 points, maybe take this one here and that one as well. This is right here. Okay, so let's call this one C, and this is D. Okay, let's get the coordinates of those points first. What are the coordinates of C? The coordinates of C here are, start with the X, always start with the X. This is the X-axis, this is the Y-axis. So that's 2, and the Y is 1. Okay, this is what we call an ordered pair for a point. 2 coordinates, the X and the Y. Again, we discussed this in detail in the previous lecture. What are the coordinates of the point D from the graph? This point here. Everybody, what are the coordinates?
3 and 2.
3 and 2.
Yes.
That's right. So 3, X is 3, and Y is 2. Good, so that's the first step. So we need 2 points in order to use this formula. As always, you want to label your points first. You want to label them. So this is the first point. Call it X1, Y1. Then you label the other point X2, Y2. And that's the slope formula. So we're going to plug. So M, or slope, M2, will be Y2, which is here, 2, minus y1, y1 is here, over x2, which is 3, minus x1. x1 is here, that's 1. If you simplify this, you get 2. And, 1. And half. Okay, that's the slope of this line. There's a little issue here. Everything is good, but we have a little issue. So the thing is, they shouldn't have the same slope. As we said, from the graph, this one is steeper. This one's supposed to have a higher slope. But before, I didn't use graphing paper. I used just random numbers here. So these are not accurate. So what I'm going to do is I'm going to try to use graphing paper. Okay, I'm going to grab a couple of graphing papers here. I'm going to try to use more accurate readings. So the method.
Professor, sorry.
Yes.
But x1 is 2, and you wrote it.
Okay.
You wrote 1.
All right. You might be right. Actually, yes. That's right. So x2 here should be.
X1 is 2, and you should.
That's right.
Yes, you should write. Yeah.
So this should be a 2 here. Thank you. That's how that makes more sense.
Yes.
Very good. So that makes more sense. So this should be 1 over 1, which is 1. So now that confirms the theory we talked about earlier, which is M2 higher than M1. So this is steeper as it looks here than this one. So this one is expected to have a higher slope than this one. And indeed, as you can see, M2 is 1 and M1 is 1/2. Okay, so that's basically the idea of slope. Just remember the steepness of a line. The steeper the line, the higher the slope is, or the higher the absolute value of the slope, because sometimes the lines might be going that way. So the higher the absolute value. We'll talk about this a little bit later, about the signs of the slope, depending on which direction or which way the line rises. Okay, so that's basically the idea. That's the formula. So remember this. This is what we call the slope formula. We have a couple of more formulas we're going to talk about later. They're going to be based on this. So this is a very important one. Okay, so let's do another example. So sometimes you don't have a graph. Okay, again, these graphs are made up. Usually if I give you a graph, I'll give you the actual one with actual numbers and the scale. Or instead of giving you a graph, I'll just give you these points right away. Okay, you may have just 2 coordinates without the graph. If you have a graph, you can read any points on your own. You can take any 2 points. But it may give you 2 points, for example, it may say -2 on 1, and another point, maybe 3, -4. Okay, let's say find the slope. Okay, so find the slope of the line with these 2 points. So these are 2 random points, for example, this and this, and there's a line that goes through them. And we want the slope of that line. The slope, we want to see how steep that line is based on these 2 coordinates. So same way, I'm just going to label these, use the formula, and find that point or the slope. So again, the slope formula is, so label your points x1, y1, x2, y2. Okay, so the difference of the y's, just remember the top, just subtract the y's, and the bottom you subtract the x's. In the same direction, you can do them this way, this, and this, or you can do them the other way. It doesn't matter, as long as you do both in the same direction. So let's do y minus this. Okay, so y2 is -4. This minus here, and y1. So y1 is 1. Be careful when you plug the numbers, especially if you have negatives in the coordinates. It's very important that you be careful and put exactly what you have. For example, for the bottom part, be careful here. So x2, write down whatever x2 is. x2 is here is 3. And right away, put this minus that comes from the formula. Okay, and then the value of x1. So put this this minus, there's always a negative there. And then whatever the value x might be, could have another negative in it, it could be positive. In this case, what is x1?
-2.
Is -2. That's right. As you can see, we have two negatives here. One comes from the formula. Second one, x1 happens to be negative. So we have a double negative. Don't ignore that. Same thing here, we have two negatives because y2 happens to be negative. We put the negative here. Then minus, we put the minus here, and y1. y1 is 1. So a bunch of negatives here. -4 minus 1, minus 1 is. Everyone, please, I want to hear from all of you. I don't want to be talking to one personally. Please engage, ask questions. What's -4 minus 1?
-5. -5.
Okay, -5 over. So for these two, how do you simplify this? First, we need to turn the double negative. The opposite of -2 is +2. So negative and negative turns into a +3,
1.
2. That's right.
Oh.
-5 over 5, which is
1. -1.
-1. That's right.
Yes.
As you can see here, so the slope can be negative and it can be positive. We'll explain why. There are four cases for the slope. So it could be a negative number, could be a positive number, could be a whole number like this or a fraction. So let's discuss when the line, when the slope is negative and when it's positive. We're going to call this the size of the slope, or of the slope. So there are four cases you might see with the slope. Let me make 4 graphs here. So the line, I'm going to make 4 cases or 4 possibilities. So the first thing is what we saw earlier. So the line is like this. So it goes up or it slants from right to left. When the line goes up like this from left to right, the slope will be positive, just like these two. They both go up from left to right. They don't fall down like this. That's why they slope, both of them are positive. So positive slope here. And if instead the line, instead of going up from left to right, if it falls down, that's how you know your slope will be negative. Okay, so the line either goes up from left to right or goes down from left to right. The line could also be something like this, a vertical line. Okay, so in this case, the line is vertical. It's not steep or not inclined a lot to the right or to the left or slanted. It's just a vertical line. In this case, when the line is like this, the slope is undefined. Slope, or let's say undefined slope. You don't have to do any math. If you do the math, you will find an undefined value. I'll explain that later. So undefined slope. So remember, if a line is vertical, that means it forms a right angle here with the x-axis. Okay, that's a right angle. So there's no slope, no need to measure it. If you measure it, when you do x minus x, it will be 0 here. It will be 0 in the denominator, and you can't divide by 0. It will be undefined. Why? Because the x here is the same. X does not change. The whole vertical line, the x is the same. For example, whatever it might be here, for example, 1. So all the x's on this line are 1, 1, 1, 1. The only thing that changes is the y. Y, for example, 1, 2, 3, or 4. So if you put 2 points here, any 2 points from the line will have the same x. For example, in this case, 1 minus 1 would be 0. If you divide by 0, you get something that's undefined. So division by 0 is not possible. That's why we say vertical lines have undefined slope. Okay, that's the case when you have a vertical line. Then you may have a horizontal line. So when you have a horizontal line, in this case, we say the slope 0. Slope is equal to 0. And it's very easy to see that because when we do 2 points from here, for example, if you take any 2 points from this line, from example, here and here, and let's say this is probably 2. So any 2 points would have the same y. Any 2 points from this horizontal line would have the same y. That means you will have the same value here minus itself. So 2 minus 2 in this case here will be 0. So 0 over anything is 0 as long as this one is defined. So it's okay to have 0 here, but not here. If you have 0 here, that's undefined. If you have 0 in this numerator, then this turns into 0. That's why whenever you see a horizontal line, know that the slope is 0. You can try it yourself. You can try a couple, any 2 points from that line, and you'll see that you will end up with 0. So vertical line, undefined, horizontal line, slope is 0. You can, again, prove it yourself. Easy to prove yourself. Take a couple of points, plug them, and simplify. And for these lines, we need 2 points, as we did here. And be careful when you plug your coordinates, and you'll see that some lines are positive, some slopes are positive, some are negative, like this one. That's how you know that your line goes up from left to right, or it goes down. Okay, so those are all the four cases or possibilities of slopes. So the sign, or the direction, or the way the line goes up or down, at least gives us the sign of the slope. It may not give us the value. For example, you may not have the value. You will have to take 2 points, like we did earlier, to find the slope, but at least gives you the sign. For these, we know the value if it's vertical. If it's vertical, I mean it's undefined. If it's horizontal, the slope is 0. Okay, does that make sense, everybody? Jessica, Lordine, Rasha, Raul, Jennifer?
Yes, of course.
You guys there?
Yes, Professor.
Zubaro?
Yes, Professor. Yes, Professor.
All right, so that's the idea of it, okay? Just remember,
Okay.
it measures the steepness of a line. It measures how steep a line is. That's all there is to it. And to measure it, we need the slope formula, which we find this way. We take 2 points, we subtract the y's, and we divide them by the difference of the x's. Gotta be the y's on top and the x's at the bottom. I'll explain why later. This is called the rise and run. Okay, so there's a form. We did that. So now we're going to see how to graph. Lines. This actually should have been 3 here. So let's introduce what we call this, the slope intercept. Another formula, the slope-intercept form. So this is the slope form or formula. We have another one called the slope-intercept form, which is given like this: y mx plus b. That's the slope-intercept form. Why we call it so? Because that's m, that's the slope we've been talking about. Then we have another number here, the b, which we call the y-intercept. We talked about the y and the x-intercept in the previous lecture. Please rewatch that, review it if you haven't done yet. Intercept. Basically what it means is the interception of the y-axis, for example here, and the line. This is the line. This is the y-axis. This is what we call the y-intercept. It's basically where the y-axis and the line, whatever line you might have, for example here or here, that's where they meet. So it's called the y-intercept or the y-intercept. So that's basically what the y-intercept is. That's the reason why we call this formula slope-intercept form, because it has a slope and it has the y-intercept. And the good thing about this formula is you don't have to find the slope. You can just read it from here. So if you see an equation in this form, you don't have to use 2 points or the slope formula to find the slope. You can read it right away. For example, if we have an equation like this, 3x minus 2, what is the slope of this line? What is the slope m if you look at the standard form? This is the slope, right? M is always next to the x. So what is the slope of this equation on this line? Are you guys hearing me?
Yeah, we can hear you.
Okay, what is the slope? Just read it from here. You don't have to calculate it, just read it from here. So this is the slope-intercept form.
So we should put these numbers into the form, right?
No, you just need to read it. What is the value? Just give it to me from here. So the slope.
Y equals 3 times negative 2
what is m?
minus 2.
What is m? M, the slope. What is the value of m in this equation? That's what the slope is. The slope is this value here, m, next to the x, right? In this equation, what is the value of m? You don't have to calculate anything. You just have to read it. You just have to see it and tell me what the value is.
I'm looking for
1.
The value m is next to the x. What's next to the x here?
2.
2.
Negative 2 minus 2.
What is
Oh, 2.
the x? What is next to the x in the place of m? What is the value that's in the place of m?
3. 3.
3.
3. Okay.
That's the slope. You just have to read it. So this is the slope m. This is the intercept. This is where the line meets the y-axis. So this is the y-intercept. Again, this formula is convenient because we can read the slope right away. We don't have to spend time finding it or using the formula or 2 points. We can read it right away because of this very convenient and useful formula called the y or the slope intercept. Slope intercept because it gives you the slope, it gives you the y-intercept. This one we saw here earlier, it's also the equation of the line, but this is standard form. This does not give you the slope right away. You will have to do something first before you can find the slope. So this is standard form. It's an equation of a line. This can be changed if we do a couple of things. So you can change this into this form. That way you can read the slope. Okay. So when it says give the slope of a line, if you have 2 points, you can use those 2 points to find it. Or if you have an equation like this, you can just read it right away. Let me give you another example. So y negative 2x plus 5. Okay, what is the slope of this line?
-2.
That's right, the slope is right here. So m is 2. What's b, or the y-intercept?
5.
That's right, 5, or positive 5. Sometimes it's a negative, but here it's positive. So just read that value next to the x. What about this one here? X plus 1/5. What is the slope of this line? Well, in other words, what number is next to the x?
1.
That's right, we have an invisible one here.
Yes.
Okay, so could be a negative. If you see a negative, it would be -1. You don't see a sign, it means it's a positive. There's always an invisible number here, so that's 1. And of course, the intercept is 1/5. Okay, so that's, again, the slope intercept form. We can easily read the value from that, from the equation. But if the equation is, the equation is not in this form, it has to be a y by itself on one side and then the rest on the other side. We'll talk about this one a little bit later. Okay, now that we know the slope intercept form, we're going to see how to use it to graph a line. So last time we saw to graph lines, we did a table, we did a bunch of points. Today we're going to see how to graph easily, almost immediately, using this formula, which is very convenient. So graphing. So graphing lines using the slope intercept form. So basically what this is, going back to the slope. So slope is a number, right? Which we said is, this is the formula for the slope. Okay, there's another name for this. So this, whatever difference you get from here is called the rise. And the bottom part is called the run. Okay, that's just another name for the slope. This is how you find it. It's also called the rise over run. Let's see what that means. So when you take 2 points, take this line here. So you have 2 points, and you want to go from one point to the other. Okay, as we saw earlier, we had A and we had B. Let's say you want to go from here, you want to go from A to B. You do this in 2 steps. We go up, and then we go right. When you go up, that's what we call the rise, because the Y changes. You can see the Y changes from Y1 to Y2. So if this was Y1, so you go up here, this would be Y2. Okay, so to go from A to B, not directly, we break this into 2 steps. The rise, that's when you go up. That's why this part is called the rise, because we rise from Y1 to Y2. And to find that rise or that difference, we subtract the 2. We do Y2 minus Y1. Then you go to the right. When you go to the right, as you can see here, so basically the X changes. So here you have X1. Over here you have X2. Okay, so that change here, change in X, is called the run. It's either to the right, sometimes you may have to go to the left. If the line is going that way, you go to the left. On the rise itself, You either go up, sometimes you may have to go down again if the line is slanted from left to the right. So that's the idea of rise or run. It just means change in y over change in x. And by graphing or from the graph, you can see to go from one point to the other, you may have to rise and then run. Okay, so the difference of y, difference of x. So that's important. We're going to see how to use this rise and run to graph lines that are in this y-mx form. Okay, so this is y-mx plus b, famous useful formula or slope intercept form. So let's see some actual examples of that. So graphing, for instance, y is 2 over 3 x maybe plus 1. So that's an equation which happens to be in the slope intercept form. It's not always the case. It might be sometimes in this form of standard form, which is not as convenient. So to graph this, so first you want to get your slope and y-intercept. What is the slope again of this line? If you read it from here, what's the slope?
2 over 3.
That's right, the slope is always next to the x. Could be negative, could be positive. In this case, it's positive, so 2 over 3. And again, what's the other name for a slope? What do we call the top and the bottom?
Rise and 1.
That's right. It's also called the rise and run.
Rise, run. Yes.
And what do we call this number here? 1 is, that's b, or the y-intercept.
Intercept, yes.
Also called the y-intercept, which is 1. And again, we said it's called the y-intercept because that's where the line meets the y-axis. So this line here, we don't know the graph yet. So we want to find the graph of this line, something like this. So we need a graph first. This is the x-axis, this is the y-axis. So to graph this, we need two things. We need the slope, which is here. We need the y-intercept. So first, always start from here, the y-intercept. So this is again where this line, this graph meets our line. However the line goes, it's going to meet this line on this point y positive 1. So y positive 1 is here. That's the first point of the line. If it's negative, then it would be down here. If it's 0, it will be here. So that's the first point. So you want to start from the y-intercept, and you put that on a graph. And from that point, from here, we need to go to the other point. As we did here, we need to go to the other point. To do so, we need to do rise and run. As we said here, rise and run. Those we have them here. They come from the slope. Okay, rise over run. So from here, we're going to rise 2 units. So from that point here, we'll do the rise, which is 2. So we're going to rise 2 units from here. Not go to 2, rise 2 units. So we have 2, 3, 4, 5 here. Start from the y-intercept, which is here. We're going to go up 2 units, 1 and 2. Okay, we have 1, 2, 3. 2 units from here would be 1 and 2. Then once you get here, we need to do the run. The run here is 3 units. So we're going to go 3 units to the left, to the right. So again, start from here, go up 2, then to the right, 3 units. So start from here, go up 1, 2, then to the right 3 units. 1, 2, 3. Not because of this 3, because of this 3 here in the denominator. So start from 1, go up 2, 1, 2, then go to the right 3 units. 1, 2, and 3. And that's it. That's the point A, and that's the point B. That's all you need to graph the line. So now we can join those together with a straight line that goes like this. So this is the line This is the graph of line 1. If you call this line 1, this would be the graph of line. Okay, so that's a very quick method of graphing straight lines when you have an equation in this form, the y mx form. This y mx form, because it gives you the slope, which is the rise and run. It gives you the y-intercept. So you start from here, wherever this one is, it has to be on this axis, always on this axis. You label that point, you mark it, then you try to go to the other point by doing the slope, rise and run. And depending on the sign of these, so if they're positive, this number is positive, we go up as we did. But if you have a negative here, instead of going up twice, instead of going up, we would go down. Similarly with the run. If it's positive, we go to the right, but if it's negative, we go to the left. Let's see another example, maybe with something negative here. Let's say y and negative 3/4. Let's say probably negative 2. So that's another line in y-mx form. As always, get your slope and y-intercept. What is the slope of this line? What's the slope m?
Negative 3/4.
That's right, negative 3/4. And the y-intercept, v, is?
-2. Negative 2.
That's right, negative 2. Once we have those, now we need to graph, so we're going to need a graph. If you have graphing paper, you can use it, it's better that way. You can print out graphing paper online. All right, so where do I start to graph this line? So this is the graph, empty graph. I want to graph this line. I have the M and the B. So where do I start from?
From B.
Say again?
From B.
Okay, and where do I find B exactly?
You put -2 on Y.
On the y-axis, that's right. Always start from this point on the y. This is the y-axis. Whatever sign it might be, it's got to be here. So it's a negative, so this time it's got to be over here. So this is the first point here. Start from the y-intercept, which is -2. Okay, now where do you go from this point?
You rise -3 points.
Does
go down.
Go down.
Yes.
So we're going to start from -2. Since we have a negative here, instead of going up, even though it's called a rise, it doesn't necessarily mean you go up, depending on the sign of this number. So it's negative, so we're going to go down. So start from here, go down 3. 1, 2, 3. So we have -2, -3, -4. This would be -5. So start from here, go down 1, 2, 3. And where do you go from here?
4 points to the X.
Or right or left?
It's right.
Right, so we're gonna go. So we went down 3. Now we're up to 4. So 4 is the run. It's either left or right, depending on the sign of 4. It's a positive number, so we're going to the right. If this was negative, we'd go to the left. So again, we start from here on the Y, went down 3. That's the rise. Then we're gonna go 4 units to the right on the X. So start from here, go down 3, 1, 2, 3. Then go 1, 2, 3, all the way across from, this is 4 here. Went to, okay, 1, 2, 3, 4 units to the right. I said that your starting point is the intercept. Second point is, after a rise and a run, you end up here. That's it, those are the points we need. You take your ruler and you draw the line through them. So this is line 1. So this is basically the graph of line 1. Okay, so as you can see, this is the, so we had to go down. Okay, so go down. So this is the rise, -3. And then we go to the right, that's the one, which is 4. 4 because of this, and this is going down 3 units. And you end up here, and that's our line. So first line, first point, starting point, the ending point, and then you do the line through both points. Okay, so that's basically, you can do this very quickly, unlike the method we learned the previous lecture. So the previous lecture, again, that's when we started talking about linear equations, and we saw how to graph them when we had equations in standard form. If it's in standard form, so we need to have a table as we saw last time, the X and Y intercepts like this, and maybe another checkpoint. So we have to fill up this and then plug these points into a graph, then draw the line. If you have standard form, but if you have this convenient formula, the slope intercept form, it's very easy because it gives you the slope. You don't have to find it. It gives you the Y-intercept, and also you can use it to graph the lines immediately. Everybody, any questions? Is everybody on board? Jessica, Lordine?
Yes, sir. No questions.
Yes, sir.
You guys okay? Any questions?
Yes. Okay. No, thank you, sir.
Please feel free to ask and engage. Okay, I keep asking you, so let me know if you have any issues.
Okay, thank you.
Let's see what else we have to talk about today. So slope intercept. So another thing with, sometimes you can write, so see how from here we extracted the M and B from the formula. We can go backwards. If we have these and you don't have the formula, you can go backwards and write an equation. Basically, simply by plugging these two values into this form here. If we have M and B, we can substitute them here, and then we have our equation. So it's very simple. So let's call this a writing. We're gonna write, this would be number 5. So writing equations using the slope intercept form. Example, this is very simple. So if you have M, if slope M equals, let's say 7, and Y-intercept B equals -3. What is the equation with a line with this slope and this intercept? So first we need to write down our equation. This is the standard form. This is a standard form. All you have to do is take the M, plug it here, take the B, plug it into this, and you'll have your equation. So M will be Y equals what? M is 7. Keep the X there, and the B is -3. That's it. That's typically question you'll see in the exam or quiz or homework. All you have to do is plug the values of the two of the points of the values of M and B. Another case here of graphing lines, forgot to mention, sometimes to graph, let's say you want to graph another example here, maybe Y is, let's say, 2x plus 3. So here, if you want to graph this one the same way we did, first we need the m. What is the m of this line? What is the slope of this line?
2.
It's 2. But in terms of a rise on the run, we need 2 values. So this is a rise. What is a run? So the rise on the run, the slope has to be in this form to graph rise over run. If you have 2, but you don't have a denominator here, for example,
It's 1. It's 1.
that's right. You can just put 1 here. So if you don't have a denominator, the run is 1. And this will be the rise on the run. Okay, so when you graph, we need to do this. If you don't have a denominator, feel free to use 1. And if this was 1, if we have x here, for example, just x without the 1, without the 2, that means the slope would be 1 over 1. Or if you have negative 1, it would be negative 1 over 1, and so on. So the run, if you don't see it, it means it's 1. So that's basically how you write your equations using slope-intercept form. You just plug your points, plug the m and b into the equation, and you get your formula. And the last part is how to graph. So how to graph horizontal and vertical lines we talked about earlier. They're easier to graph. Okay, we said earlier that the line could be positive slope, negative slope. Could be like this, or it could be like this. So for this line, as we saw here, this is the x-axis. This is the y-axis. So the equation of this line, basically, the x is fixed. The x does not change. As you can see, x is 1. The y, however, changes. So the x is 1. So the equation of this line is just x equals 1. That's it. That's the line. That's the equation of this line. x1 because it's fixed. This one, however, the y is fixed. The y is 2. So what is the equation of this line? If this one is x equal 1 because x is fixed, what is the equation of this one? Would be y equals
3.
Where do you see 3?
2.
That's 2, right? Because it goes through 2. That's it, because y is fixed. That's it. The equation has only this, not this. Because these are special lines. They only have one variable that changes. The other one is fixed. So x.
So I thought that was a 3. Sorry.
This one is, yeah, a little small. That's 2. Now let's see how to graph those. So we can write the equation easily right away from the graph, or we can graph them easily also. Let's say x is -3. So how do I graph this one? What kind of line is it first? Is it horizontal or vertical? This one.
It's horizontal. It's horizontal.
The x is fixed, so it goes through x, right? It goes through x -3.
Oh, okay.
It would be
vertical.
Would be right here. That's right. So it goes through. If it goes through x, that means x is here. That would be vertical here. Okay, so that's this line. Same way, if you have y is, for example, 7. So what is this line? How does it look like? If you want to graph this line.
It's on the right side of x.
It goes through what point? First of all, is it horizontal or vertical? And what point does it go through?
It's vertical.
I mean, you're right. It's vertical. I actually meant to put y here. Right. So this x7 will be like this. That's 7 here.
Yes.
I meant to put a y here. So what kind of line is it?
It's horizontal.
That's right. Horizontally goes through what number of the y?
Or 7.
7.
1, 2, 3, 4, all the way to 7. So we can do. So this is 7 here, and that's the graph of that line. So these are special ones, or easy to graph, easy to write the equation. Other than that, we use the full formula depending on what we have. So again, this is what remember the notion of the slope. It just means the steepness of the line. This is how you find it. Keep in mind, the steeper the line, the higher the slope, or the absolute value of the slope is. All the possible lines or slopes are here. And slope intercept form is very useful because it gives you the slope right away. It gives you the y-intercept. So you don't have to find the slope. If it's in this form, it's already there. But make sure the equation is in this form. That means the y is by itself and everything else is on the other side. In that case, the slope, or rise over run, is next to the x, and this is the y-intercept. This is where you start from when you graph. So when you graph your line, you want to start from here first on the y, then your rise and run depending on the sign. And that's pretty much it for today about the slopes. We will do more about writing equations next time. Yes, you have to write equations when we don't have this, or we don't have this, or when we don't have none of them. Okay, so that's basically that introduction to the slopes. We're going to talk about them more in the future, but make sure you understand this well. Make sure you rewatch the video. I'm going to post it. But before that, rewatch the previous lecture when we introduced lines and straight lines and graphs. You want to understand that first. Rewatch it, and then rewatch this, and then work on the homework. And if you have any questions, anything you don't understand, please write that down and let me know.
Alrighty, thank
Okay?
you.
Any questions?
Thank you.
Concerns?
No questions.
All right, so